Okay, so as we did in the previous section, we're going to create an experiment, and this time we'll call it experiment A with a subscript P to denote that the probability of success for our basketball player is P instead of 0.5 as it was in the last section. Okay, let's assume our basketball player with a probability P of making a basket on every shot keeps taking baskets until they miss a shot. As with our previous experiment A, the sample space here is an infinite sample space. They might miss on the first shot and then that trial of the experiment is over. Or they might get a basket and then a miss, and as soon as they miss, they stop. That trial of the experiment is over. But that run of baskets could go on for 2 baskets, 3 baskets, or it could conceivably go on forever, although it's highly unlikely. We can assign probabilities using independence now because we have this concept. We have the probability that they'll get a miss on any shot is 1 minus p. The probability that the first shot is a miss is 1 minus p. The probability that they get a basket and then a miss is p times 1 minus p. It's the product of the probabilities of those 2 events. The probability of a basket and a miss is the product of the probabilities, which is p squared times 1 minus p. And now we have this table of probabilities. In the left-hand column, I've counted the number of baskets in the run corresponding to the particular outcome. And the probability we get a miss is 1 minus p, as I said before. And the probability we get n baskets followed by a miss is p to the n times 1 minus p. Here we show the pictures of the distributions for 2 particular values of p, where p is 0.25 on the left and p is 0.75 on the right. And as you might expect, longer runs of successes have a higher probability if the value of p is higher. So for example, if p is 0.25, then the chances that I get a run of 6 baskets followed by a miss is approximately 0.0002. Very small, in fact so small that it doesn't even show up on my graph of the distribution. On the other hand, if p is 0.75, which is relatively high, the probability of getting 6 baskets followed by a miss is 0.0445, which is much higher, and you can see it does show up on my graph of the probability distribution.